During the next hour and a half, we will welcome 3 organizations that actively contribute to More Than Planet with their expertise. But first, Mia Turzish, an artist and a researcher who is the general coordinator for More Than Planet, is going to give us a short introduction to More Than Planet workshop program in which our next guests are involved. Miha?
So for the introduction into the next session, let me just quickly show something more visual, because Marco before already, okay, let me just jump to the right place. So Marco already explained with words in what kind of efforts we are. I'm going to be a bit more visual and a bit more concrete, more structural, because all the efforts that we do, especially at WAG, we also work with John with territorials, also with Space for Good, that we'll talk later on. And our effort in which we are, as I already slightly mentioned yesterday, we work on the question, how do we portray our planet? So it's not just a question of the environment, it's not just a question of society, but the planet as a whole, as a concept. And how do we understand this kind of effort? Because there are kind of a mainstream imaginaries about the planet, mainstream understandings, but there are also some more emerging ones and also those that are literally not born yet. So I think we need to work on these kind of efforts. And in this context, we are developing something that we call a planetary public stack. So the whole stack of activities, technologies that help us as, let's say, creative and critical thinkers and makers make these portraits of the planet. And so that's, let's say, basic structure. It's a kind of a foundation where we study and research the comparative planetology. So how in different ways we understand the planet as a whole, what kind of concepts exist and what kind of concepts we can make, and how can we make planetary concepts, how they matter to different people on the world, not just human people, but also others, in what way we can or we should collaborate in this context, because we know that we cannot go to space alone. It's always a collaborative effort, and that's why also today's event is an input to our understandings. What kind of data, tools, technologies we're using in this context, because the planet as a whole is just a bit too large, too big for individuals to cope with them, and we need technologies in this context, and we are using them. And then also what kind of narratives and interfaces are emerging in this context, where all the public imaginaries are then later produced. So our next speakers will address some of these topics. Some of them were also produced with them and is still ongoing. In the Netherlands, we're still running a series of workshops, especially with Space for Good, with 30 artists working on these questions, working with these approaches, working with these structures, and trying to produce understanding how do we portray, how do we understand our planet. Thank you.
Thank you very much, Miha. So we're now welcoming John Palmesino for Territorial Agency. John Palmesino, you are the co-founder of the independent organization Territorial Agency with Anna-Sophie Honskog. Territorial Agency combines contemporary architecture, science, art, advocacy, and action to promote comprehensive territorial transformations in the Anthropocene epoch. Recent projects include Oceans in Transformation, commissioned by, and here please fasten your seatbelts because it's a very long list, TBA 21 Academy at Ocean Space, ZKM Critical Zones, Taipei Biennale 20, Ars Electronica, Beaux-Arts, Sensible Zone at la Biennale di Venezia. I'm trying to do the accent, probably very badly. Seoul Biennale of Architecture and Urbanism, Barbican, London. Warsaw Biennale, VAG. Museum of Oil with Greenpeace, ZKM Reset Modernity, and Chicago Architecture Biennale, Anthropocene Observatory, and at HKW, Haus der Kulturen der Welt Berlin, BEK Utrecht, and in the collection of Central Museum Utrecht. Territorial Agency is the recipient of the STARTS Prize 2021, Grand Prize of the European Commission honoring innovation in technology, industry, and society, stimulated by the arts for oceans and in transformation. John will introduce us to Territorial Agency Tech on Oceans.
Thank you. Dear friends and members of the audience, I am gonna start, or let me start with noise. And it's gonna be a couple of minutes listening to a sound that has been transformed from complex data, that is planetary data, gathered by the CTBTO, the organization of the United Nations that is the responsible for the comprehensive treaty for the ban of nuclear tests. And you are, I think, as well as we are, constantly on the alert with them, trying to understand whether a nuclear test explosion has taken place. The majority of us might hear about an eventual nuclear test through the very complex media of the news, of Instagram, and so on. The CTBTO scientists listen to the Earth in search for signals against the noise of the Earth. The signal is very complex, and it's in reality an infrasound set of sensors at the bottom of the ocean and a series of seismic sensors sensing the tremors and the activity of the Earth. And they try to, with very complex mathematical models, determine whether the signal has any discrepancies from what they understand. They never listen to this because it's really inaudible. So one of our colleagues from Territorial Agency has embedded himself as a researcher in CTBTO, has become a fellow researcher, and this is what he managed to do. I hope it's going to be loud. Does it play? So these are just 1.5 minutes, almost 2 minutes of earthquakes, shoals of whales, and the repetitive sounds of the global supply chain of the shipping routes passing by, a meteorite coming through the atmosphere. And the question, of course, is that when you're trying to listen for an event that is so rare as a nuclear explosion, most of the time you spend listening to the Earth. And the question I want to pose today as part of the project on ocean, space, ocean in the planetary stack, or in the public planetary stack of Modern Planet project that we are embarking on with our friends at VAR, is really how to become sensitive to the conditions that are transforming the Earth. And I'm going to do this by largely going through a project that we've developed with TBA 21 Academy on a commission by Francesca Thyssen-Bonamiza and Marcus Raymond of TBA 21, called Oceans in Transformation. And I will start really with indicating how we initiated the project so that you have maybe a methodological idea of how we operate at territorial agency. The first step was to be above, to look at the ocean like we all do from above. And the ocean, when you are above, is the horizon. Now, horizon is the interception of sight with the surface of the planet. It is a space that marks your position, but it also is a space of transient flux. It is that space where materials disappear and come back, where languages become materials, where ideas operate. It is a tangential condition. It's the tangent of sight with the planet. On land, horizons are rapidly transformed into demarcations and redistribution systems. They form boundaries and they channel spaces where differences are marked and inscribed. When above dry land, horizons are how we articulate our location. Horizons both mark our location and they form a backdrop. They are the multimodal space that rapidly exchanges materials and information, as I said, that transforms material practices into ideologies. Horizons always precede redistribution and always precede ordering. And at Territorial Agency, we are really interested in this space of the horizon because it's the space where the materiality of the fluxes, material, information, and energy fluxes that mark contemporary life on space become tangible. Today, horizons are swollen. The horizons are rising through sea level rise. Together with the ocean, the horizon changes. And the horizon of sea level change is only visible through the complex mediations of the models of sea level, through the complex orbital stations and receiving and transmitting compounds that form Earth observation, through the very complex gauges in the bays, and through, of course, memories, recordings, and institutional bureaucratic recordings of shipping. From within the Earth system of our contemporary logistical capitalism, sea level change is invisible. And yet, it is the very technologies that guarantee the making and the transformation of contemporary logistical capitalism. The logistical being not only the site of shipping, but the constant certification of origin, constant certification of your identities, and the incessant, thunderous attempts to constantly ameliorate your lines of work, your trajectories in that space. From within that space, we don't see the horizon of the sea changing. We see it as a stable condition. We imagine it always as a stable condition. And when we started the Oceans in Transformation project, we did this little exercise, which is trying to get the Paris Agreement, which was done in 2015, with all our contributions. Now, we tried to make it work. The minimum aspect of the Paris Agreement, trying to keep Earth within 2 degrees warming from pre-industrial level, implicates locked-in energy that will swell the horizons to 3.6 to 6 meters in the coming century. Locked-in energy because of the greenhouse gases, the debris of the technosphere, which will cover areas that are currently inhabited by around 600 million people, and where 1 billion people today have direct dependencies. It is that space that we are interested in discussing. How do we become sensitive to that sensorial condition of the Earth system analysis and the very complex Earth observation structures and what we thought was the stable horizon of our planet? What are the horizons within water? What are the horizons when we have multiple echoes, refractions, swellings, and movements? How do we become attuned to an Earth that is rapidly changing? These are some of the questions that Oceans in Transformation tries to intercept. It's a project that develops over multiple years through encounters with scientists, scientific groups, institutions, some of them very large, like Scripps Institution or Woods Hole, MIT, the European Space Agency, the European Commission, the very complex attempts by the great Pacific states to make sense of what is happening. And the project is really trying to simultaneously make sense of the new horizons within water, where we don't recognize what we are looking at. Like in this case, a multi-temporal transformation of the coast of Bohai Bay, the location of the majority of the shipping routes origin out of China. We don't make sense of that, and we need to pay attention simultaneously to the very rumbling sounds of the technosphere rising and the fragile conditions of ecology. So this is really the location that I wanted to bring you in with that thunder at the beginning. What is it? It's obviously not the sound that you will think is appeasing. It's not the sound that you imagine the ocean being. It's not the sound where you will immerse yourself and think that you will be happy. And by the way, sound in water travels much faster than in air, and the amplitude of the waves of sound are much higher. So you have simultaneously the conditions of equivalent to those of being on a runway listening to a jumbo jet taking off, and the range is much higher. And that means that you can hear that sound really far away. What we are having at the moment is a condition where the Earth and the Earth is an ocean, is becoming sensitive to this other sounds, this other noise, which is the technological noise, machines, drillers, passageways, exploration, extraction. You know, whenever you're clicking and buying your new book, you're accelerating that set of sounds. So how do we become attuned to this? And this is really where I think I wanted to have the discussion today about ocean, space, ocean, really to make us think of a very simple condition, and that is the horizon, when within, needs to be changing completely the relationships that we have in our territorial thinking, in structures of property, in the complex way in which we can hold on to something or structure relationships of exchange, or how we organize the relationship between a polity, an institution, and the spaces, the material and the information and energy fluxes that we inhabit. So this is really a very simple question. How do we start sensing the ocean that is sensing us? And the question is also, how do we start thinking today as if we would be not above, but within a condition of sea level change? Just to remind us, the line that you see here in white on the facade of the Church of San Lorenzo in Venice is locked in energy. Sea level rise locked in at the level of warming 2 degrees that we might achieve if we are all good boys and girls. We have 30 years ahead of us to decarbonize our democracies. We won't decarbonize the totalitarian states. We will only decarbonize our democracies. And in those 30 years, if we're all good boys and girls, we'll create a situation where the ocean, which is now at that level in the front, the canal, the water will be up there. So in these 30 years, we have enough time, and we are about to run out of time, to keep oil in the ground, to re-articulate our societies, our democracies, and restructure conditions of operation. The horizons of sea level have never risen so fast. The last time they rose so fast was at the end of the glacial period. At the last rise of the seas that is similar in speed to the one that we're experiencing in the last 50 years. Our ancestors, 12,000 years ago, reinvented cosmologies, reinvented notions of agency, the location of agency. They reinvented conditions of allocating deities to horizons. And the most important
Mito babilonese della creazione, circa VII secolo a.C.
The most important one, I'll just leave it there because it's in Italian, is the reinvention of the origin myth of the Mesopotamian cultures, which is marked into the structures of the Enuma Elish, which is the sort of origin of all the monotheistic cultures that imagine that the creation of our world coincides with the separation of dry spaces from the ocean. And that's where our entire cosmology in monotheistic culture rises. The separation from sweet water and salty water, from brackish water. This is where we have now an accelerated condition of the possibility of transformation of the relationship to the earth. Are we to reinvent cosmological structures? Are we to invent political structures, new horizons? And this is really where I wanted to bring you very quickly and briefly on a series of images that somehow stem from the project. It's a series of images that have been gathered by territorial agency from all the scientists, and we have literally hundreds of scientists, hundreds of scientific institutions, each one with a specific focus on what is changing in the ocean. And then we bring them together. We create a stack, even though I don't like the word, using the words of Varg in that. We create, I would call them, dynamic compositions. We recompose the data and we show it back to the scientists. And that is a moment of complete disorientation. The scientists need to seriously reconsider how they understand their space. What is it that they are producing? What is it that they are looking at? And the scientists, the activists, the fishermen, the migrants, the artists, the indigenous people, the bureaucrats are brought together in the spaces of oceans in transformation, ocean space in Venice being one of them, to create a space of complex negotiation about the horizon in order to re-territorialize, in order to re-understand what are the multiplicities of horizons when we are within the ocean, when we are within a conditions that is, at the moment, only visible at the edges of the world system. How do we push that sensorium? How do we understand the oceans as a sensing condition that is sensing life on Earth and inscribing it back onto life on Earth when the only conditions that we can imagine of are those of stable horizons? So you see here how the data is compiled into trajectories that span non-continental spaces that try to intercept simultaneously tipping points of the world system and the anti-systemic narratives and ideologies of liberation and upheaval, and the tipping points of Gaia, the tipping points of the transformation of the Earth. Like in this case, the very complex warming of the mid-Atlantic, or in this space, the very complex melting of one of the third poles of our Earth, the Himalayas, on a trajectory moving south from the heights of the Himalayas to the Antarctica, and on that space encountering, again, spaces of empire. Like in the trajectory connecting West Africa to the Amazon, we encounter simultaneously the aerosols of nutrients blown by the winds to foster life in the Pacific and in South America. Here we encounter simultaneously, like in the Atlantic, the Black Atlantic, and here we encounter the Indian Gaia, the recomposition of the complex narratives of what it is to be empire. So these are just a few notes on how to think with the ocean, how to imagine the ocean, how to sense the ocean from within the technosphere, from within that new space that we all inhabit, that is made up of all of us, plus all the structures that keep humanity alive, which is a definition of a territory. Thank you.
Thank you, John. Is there any question in the public? Any questions? So I might have a question for you. A few years ago, I was working on forest policy in France, and one of the biggest issue was to introduce complexity in a way that could be transformed into policies, knowing that usually people who build policies don't really like complexity and have a really hard time taking it into account. What about that?
This is an image that might reflect on that policy. We heard before in the beautiful remote connection, the difficult question about spaces beyond jurisdiction. So a policy that is about what you cannot police, because that's what policies does, no? It polices. This is an image of 1 year fishing activities in the Pacific. And it's a very difficult image. It's composed by data of automatic signaling of vessels gathered by Global Fishing Watch, which is a fantastic organization, and then processed by Google with artificial intelligence to determine whether a movement is just someone passing by or there's a fishing activity. And these are all the fishing activities. The dots that you might see are transshipment. That means 2 vessels that are at the same location for more than 12 hours. That means there's one ship taking their catch and giving it to another ship to bring it to China or to Russia. Yeah. The circle in the middle is the exclusive economic zone, which is also a marine protected area in the Marshall Islands. The simplicity is the circle. Complexity, you might imagine, is everything outside, because this is how we are trained to imagine horizons. The horizon of simplicity that tells us how we can apportion things, and beyond, there's the forest, the space of the foreigner, of the unknown. But this is only a figure ground problem, because we know very well what all of these things are. It's not complex. It's called overfishing. And we heard exactly in the previous presentation the efforts made to even regulate that. So what I'm trying to say is that there's a huge misunderstanding when we're dealing with ocean or planetary data, that it's too complex. Hence, we should simplify it. It is very similar to, in my experience, to what you would encounter if you try to make sense of oil, of petroleum. It's impossible. It's too much information. You don't know where to start. Would you know how to stop oil extraction? Would you know how to articulate the very complex financial instrumentation that dominate our life? No, we don't even discuss that in politics anymore. No? It's too complicated. The reality is that we know that we need to keep it in the ground. We all know that we need to keep oil in the ground. We all know that we have to protect the ocean. But we don't act because we simplify. So that's my question back to you. How do you not simplify?
I don't know. Yeah. Any question, maybe? No? So we are going to move to this innovation.
Thank you.
Merci. So we're welcoming Nicolas Maigret and Baruch Gottlieb for this innovation. They will be joining us to present their research on solar share and whether it applies to oceans. This innovation is a research collective composed, whom the core members are Maria Roskovska, Nicolas Maigret, and Baruch Gottlieb. It was set up in Paris in 2012. You work at the interface between contemporary art, research, hacking, and compose tailor-made teams for each investigation, together with academics, activists, engineers, and designers, a group of contributors to which I had the chance to belong. More specifically, your recent artistic provocations seek to empower post-growth imaginaries and practices by challenging the widespread faith that economic growth and technological fixes will solve the ecosystemic disruption they produced in the first place. You recently co-edited a bestiary of the Anthropocene with Nicolas Nova and an atlas of anthropic hybrid creatures.
Okay, so yeah, we are a research-based collective. Basically, we are building teams based on each investigation. Lately, mostly our investigations are looking at the friction between economic growth and environmental or ecological crisis. And we look historically at how this type of perspective can inform us critically about our current condition, looking at the relation between ecological crisis and economic growth. We believe is a productive and interesting path to sort of decode our condition. We will look at a recent set of research that inform this question, more especially at the series of projects we call post-growth prototypes, where we are basically interviewing many academic and researchers on those research questions I just mentioned, and we try to extract key notions or key concepts from those interviews that can sort of bring those critical discussions to the next stage, or that can help us take new perspectives or new nuanced point of views around our current condition. And some of those concepts, we decide to turn them into physical installations. So when they are too abstract or too complex, or when we believe they are key to understand our condition, we try to develop them into tangible situations. So I will mention one first example, which is a square meter of wheat cultivated totally indoor. So it can remind you of many space research experiments where plants are cultivated outer space. And basically by reproducing this kind of extreme environments, what happens is that you have to recreate the functions of the ecosystems that are not existing anymore. So by cultivating in this kind of black box or out of the ecosystems, suddenly you have, visually, you have to reproduce the water source, you have to reproduce the solar source, you have to reproduce the wind, the nutrients, the soil, and so on and so on. And then you can also play the game of economics. And by playing the game of economics, you can start to evaluate or estimate what would be the cost of something as simple as a square meter of plants to make them survive if you had no ecosystems, or if the ecosystems were unhealthy or damaged.
Yeah, so it's not only plants, of course. These are special plants. The reason we chose wheat is because when we have when we see these imaginaries of the future where we're growing plants in artificial circumstances like outer space or on the moon or something, you often see leafy vegetables, salad or tomatoes or something, plants that don't have a lot of caloric value, but each and every one of us needs about 2,000 calories a day. And so we usually get these calories from some kind of staple food like wheat, right? And it turns out that wheat actually needs a lot of energy to produce. So the energy we need to make our brain function, our nervous system function, our body function, actually needs energy, which normally, conventionally comes from the sun, and we can't digest it directly from the sun. We have to get it metabolized through plants, and especially these kind of plants which store the energy well that we are able to digest.
And when you start to assemble such kind of paradoxical experiments, one thing you start to notice is that a kilogram of wheat will cost rather 300 to 400 euros and not anymore 30 cents. So we don't take it seriously at the point of thinking that those numbers are exact. we take it as order of magnitudes. We take it as using the tools of quantification to shade light or to cast light on a topic which is too complex to understand anyway. But using the tools of quantification, we end up discovering that cultivating this wheat indoor becomes 1,000 times more expensive than the current market price. And even if this number is just an order of magnitude, like an estimate, it gives us a sense of how current monetary economics is unable to translate the contribution of complex ecosystems to our livelihood, to everything we depend upon in a way. So that's basically what this project is mostly about. Oops, sorry. That's another installation. That's an example of how we document the harvest process and what worked, what doesn't work.
It's art space grown wheat. So art wheat.
Okay, as I explained, most of those research are based on interviews with scholars and academics, so those are some of the outputs. And this is the methodology through which we documented those interviews.
We interview a lot of scientists. Of course, one of the problems that we're confronting with regard to climate change or energy transition is that there's a lot of expertise, a lot of scientific research, excellent scientific research, but the scientists don't encounter each other. They don't speak the same languages, the same technical languages, and of course the public is not privy to those discussions. So we try to make circumstances under which people can encounter each other, especially like with regard in the face of an artwork which kind of allows people to encounter each other through dimensions of experience which they don't often encounter each other instead of like a non-professional circumstance.
So this second project, Shadow Growth, is a good way to illustrate that. You have this very hot topic of what is the proper carbon tax that should be put in place in different regions of the world. And those discussions are stuck in basically evaluating what companies are ready to pay. Meaning that what we call today the social cost of carbon is stuck in a place which is more like the affordable price of carbon for the companies. Actually, some scientists started to do the hard work of estimating what would be the social cost of carbon, meaning the long-term damages of each new ton of CO2 emitted into the atmosphere. And when you start doing this work seriously enough, you end up with order of magnitude of cost for a ton of carbon, which is rather closer to $3,000 per ton. The same, meaning maybe not 1,000 times higher than the current taxes, but 500 times higher. What is interesting when you start to look at this future damage, meaning the damages that we are basically putting in the future, damages that we are throwing to future generations in a way. What is interesting is that they made those statistics and those evaluations by taking things that are very grounded, very basic, like sea level rise, like agricultural efficiency decrease, things that we already know will unfold in the coming decades. And we started to put in confrontation their model, which is the shadow you see under, and on the top, what our countries consider as their economic growth, GDP. And what's interesting is that when you start confronting those two levels of reality, or those two levels of statistics rather, you realize that the shadow we project into the future is most likely bigger than anything we pretend to have produced in terms of growth. So we did that type of calculation for many countries around the globe. It can also inform us in regard to what we call the national responsibility for environmental degradation or environmental crisis or climate change, meaning the fact that not every nation around the globe have the same historical legacy regarding CO2.
One of the things we discover is that, or one of the researches shows that what we call growth is directly indexed to energy consumption. So the more energy we consume, the more we get what is counted as GDP growth. So that's why you see, well, for the global north, we used a lot of coal to power machines. And then from 1950 or so, it was a lot of oil and other fossil fuels, gas. So when you reduce the, I'll just take it. When we all know these growth curves, right, from the news and from newspapers and everywhere. And one of the things that this project does is we try to look at how incredibly abstract, or like confront the incredible abstraction of like reducing an entire national economy to a number, which is GDP. So like you compress this entire huge multidimensional circumstance of activities into just one number. And so when we put what we do here is we project, like, depending on where we are, the national curve of GDP growth of that place. So this is in the Netherlands. And then we install it in the space where it takes on its dimensionality again, or at least with a projection of the light of science or the light of curiosity. We generate shadows of the data that is GDP growth.
Okay, so it was just to warm up a little bit and present the background of the ongoing research we will dig in at the moment. So lately we've been thinking about another type of provocation that will be what if we started to describe our relation with the biosphere and our relation with our social demands as a flow of solar energy. So we all know that, you know, everything that is composing the biosphere historically is the result of, or has been fed by solar energy, right? And there are some interesting economic models and climate science models that try to describe differently our economic relation with the world through solar circulation, through a flow of solar energy through the complexity of the living in a way. So you can see it as a live, direct flow of energy through the plants, but also as a historical flow of energy through fossil fuel, for instance. But also you could almost understand the complexity of DNA and the evolutionary path of a seed, a ready-to-plant seed, as a result, a historical result of solar energy over time. So they are all very abstract and complex ways to understand this question. But it's not really new in itself. Ecological economics and bioeconomics is something that has a long legacy. But the common logic there is most of the time solar input is really like the start of the flow diagram and the start of the flow of relation, both on the circulation of energy and matter. So you can see it here through Edward Odum that almost describe social system and earth system as an electronic circuit. So it's kind of almost the most extreme simplification, but still describing the flow through solar energy. Here is a more contemporary logic that looks at floors and ceiling in ecological balances. Where can we? Okay. So we are thinking about a project that will be called the Solar Share. And that would basically rely on an alternative artist model. And we think about it as a provocation. It doesn't have to be perfect. It doesn't have to describe the world in an exact way, obviously. But more it's more something we think about as a tool to think with, a way to embrace differently our relation with the rest of life and the rest of the biosphere. So here, that would be an example of how we could start this thinking on a planetary scale, looking at how biomass is distributed over the Earth, both on land and on the ocean. And basically, you can look at it through two ways. The logic of carbon absorption, which is also the logic of sunlight absorption through plant and algae and microalgae. I don't know. Do you want to say a few things?
We can just go back one.
Mm-hmm.
Yeah, so I mean, this is one kind of playful example that we developed as a provocation to create a unit of, to try to concretize what we're really talking about with regard to energy and energy transition. The paradigm is energy in, energy out, right? We need energy from the sun in order to produce art and philosophy and do everything that we do. And the energy transition that we're confronting with fossil fuels is the same problematic. So here we create these kind of coins. They kind of look like coins. They're actually cookies or hardtack biscuits. They last forever, and each packet is equivalent of adults' daily need of caloric intake to function. So these go along with the other wheat farm that we showed before, so that you can kind of imagine that we could possibly even be trading in this kind of money form. They never go bad, so you can just exchange them as a edible money form, which incorporates solar work or solar-fed biosphere work.
And once again, we played with the edges of the logic of quantification. So we were quite amazed by some result of when you start to play with the numbers. So basically, if you look at what is the average photosynthetically active energy per square meter on Earthland, this average amount of energy per square meter is more or less what you need to cultivate wheat. So what is interesting is that this average square meter of solar intake is equivalent to what you need for a square meter of wheat, which is also the equivalent of what a human needs every day. So we have a weird unit, which is a square meter of average sunlight on Earth, that also results in like 700 something grams of wheat. That is about 2,000 calories, what a human needs for a day. So we played a little bit with those sort of basic units that are reduction of complex reality through the numbers, through the lens of the quantification and through the lens of numbers.
Yeah, so we're trying to make things a little bit less abstract, right? When we're talking about what kind of changes may be afoot when we're making these energy transitions. So yeah, we have some points here. Sunlight is the primary source of energy for most life on Earth, and yeah, we with a healthy biosphere, we can count on that, and we emerge with these plants. These plants miraculously grow for free when a seed is just dropped into relatively fertile soil with rain and sunlight, and the reason that we can survive on that is because we emerged symbiotic. To the theme of ISEA this year, we emerged symbiotic with these plants over millions and millions of years, and this symbiosis is going to be disrupted by at least this ease of symbiosis is going to be radically disrupted by global heating.
Yeah, and we were quite interested by looking at the etymology of currency. We have, from different perspectives, can be seen as the condition of flowing or the state of fact of flowing from person to person. And also from an economic perspective, it can be seen as a form of receipt for grains that are stored in a temple granary. So we played a little bit with this logic in our wheat-based currency.
Yeah, we tend to get information on the news and in the media about like with regard to dollars or euros in a kind of money form, and we want to just make it a little bit more concrete that we can actually, instead of talking about dollars and euros, we could be talking about amounts of energy stored and live energy from the sun.
So to get back to planetary photosynthesis and looking at ocean as the main observation, our next stage in this solar share project is to basically have a two scale of observation. One scale will be the planetary scale, where we will develop a statistical view of the energy renewed in a year due to solar photosynthetic intake. So basically, look through the statistics, what is the ability of the Earth system to absorb new sunlight through its plant and algae biomass. And then on the more microscopic level, we want to develop something like a 1 square meter of proof of work of the biosphere, a place where algae is being in process of capturing sunlight as you experience the installation, where the shortest path basically between sunlight and human conditions or human need is sort of materialized, and this kind of economic tide is being rendered tangible on a microscopic or human scale experience level. So those are just illustration of
concept drawings.
What startups are promising us regarding algae. And this is the common way in which you can find basically algae to consume daily.
Supplement. Nutritive supplement.
Mm-hmm.
Yeah, so I guess we'd like to hear what you think, or see if you have any responses or questions or complaints, criticism. There's probably a lot of...
Thank you very much for your presentation. Any questions? Yes?
Hi, thank you for this great presentation. I'm curious to hear more details about how you calculate the social cost of CO2. What do you put behind that?
Yeah. Well, they're actually if you go to shadowgrowth.earth, shadowgrowth, one word, .earth, you can see the entire documentation of this work. We use 3 models actually, but the one that we represent here is based on the 3rd model. I'll just quickly go through the other 2. The one is like the Trump model, which gives a very low value per ton, of course the lowest possible. Then we have IPCC models, which have a range, and that is what Nicolas was saying before. They try to estimate what corporations are willing to pay, or what's the pain threshold for a corporation to pay for the amount of carbon dioxide that they produce. At the lower threshold of the higher threshold of the IPCC. So IPCC pain threshold, we have this other study by David Archer and et al., where they are looking at what they call the ultimate cost of carbon, the ultimate social cost of carbon. We have some interviews with David. Maybe you want to play the interview? Maybe he can answer it.
Sure. Let's the scientists play.
Let's science. Yeah, exactly. We always try to make things scientifically robust enough so that scientists can criticize our work.
The social cost of carbon is intended to capture how much future damages from climate change matter to us financially today. The costs in the deep future get discounted in the social cost of carbon, reflecting that we don't really care about the deep future so much. But the impacts of CO2 release on the climate will last much, much, much longer than we will live. And so the social cost of carbon, by reflecting our personal preferences, ends up throwing away most, like 99.9% or more of the damages in the deep future because we don't care about them so much. So the ultimate cost of carbon, we designed this to try to eliminate this discounting so that it would add up all the future costs and put them all in units of present day, dollars. Kind of like a measure of the long-term climate impacts converted into units of dollars for us today. In the ultimate cost of carbon, we tried to isolate just the climate impacts as if they were being felt by us today as if we were people that were going to live forever. We tried to treat humanity the way biologists would treat a biological population, that there would be a carrying capacity of the planet which will be compromised in the future by sea level rise and by temperature changes that sort of move us outside of the agricultural best climate.
For all of you that are like, working in this realm, you're all like familiar with there's these two scalar challenges in confronting it that defy our conventional language metaphors. There's of course, the scale, the global scale, planetary scale, which we don't have any direct experience of, and we experience it through various data forms or through allegory. And we have this other time scales, which we also are quite alien to our own human experience, and especially the kind of short-term electoral cycles of politics, right, which defy how we can politically address these situations. So the Archer study, and you can read about also how they, this is all open source, how the amount of carbon emissions historically was calculated. That's also on our site. But the Archer study, the lower level of the dollars per ton is around this 2,700, and it goes up to about $300,000 per ton. I mean, it gets to absurd amounts that we cannot calculate the kinds of impacts that we're really having with all the negative externalities included. Yeah, let's see, somebody over there who I know.
Yeah, thanks. Really interesting work. I'm curious about your take on this sort of calculation or economics of, for instance, future costs or because of course it's also a political debate whether we can have green growth or whether carbon capture or carbon economy like we have in Europe, whether that will actually solve anything, or will it just become a further capitalist market?
Yeah, it's hard to say. I mean, we're working with we're developing one project which is about carbon sequestration and carbon remediation, and we're meeting a lot of various players and consortiums who are, because that's actually a European mandate. A lot of funding is going into carbon remediation right now, and it's seen by most institutional players as being kind of unavoidable, that we actually will need to produce that. But yeah, I mean, the concerns, your concerns are also the concerns of a lot of the researchers that, industrial solutions produce sometimes as much carbon as they withdraw from the environment. And the notion of growth, as we showed before, we have never had growth without more energy consumption. We always add more energy consumption. So where is the new energy going to come from if we're going to continue to grow? And the growth imperative, right, doesn't come from us. It comes from the investor class, like it comes from a kind of layer of society, a financialized realm of social activity, which doesn't have that much to do with providing what human beings need on the planet, you know, on a daily scale. There was a great debate, and you can find this online. It's like on the HKW website, so the Haus der Kultur und der Welt in Berlin. There's a debate between Bruno Latour and Hans-Joachim Schellenhuber, who's this advisor to Angela Merkel for the German government. He was traveling around the world looking at climate solutions. And Schellenhuber says in this discussion, we have all the knowledge we need now, like scientific and technical knowledge, engineering knowledge, to provide a good lifestyle, good livelihood for not adequate, not just bare minimum, a good quality of life for everybody alive on the planet right now. What we're missing is the ability to instantiate this knowledge politically. Anyway, Schellenhuber makes a strange statement after that. He says, we need to slice through the social fabric somehow to get this political agency. And then Latour is sitting there and he goes, hey, I know what you mean by slice through. We have a word for this in French, guillotine.
So we are going to end on this word, guillotine. I let you think what you want to think about it. And next is Federico Franciamore. So Federico Franciamore is here to introduce us to Space for Good, to Space for Good contribution to more than planet. Okay. Federico Franciamore, you are a specialist and project manager at Space for Good, a geospatial analytics company and certified B Corp, providing remote sensing solutions to unlock, accelerate, and scale social and environmental impact. Based in The Hague, Space for Good develops and provides scalable monitoring, reporting, and verification services for nature-based solutions with a strong focus on agroforestry, forestry, and regenerative agriculture. Space for Good is a social enterprise that specializes in Earth observation, analytics, and artificial intelligence. 80% of your team members have a respective technical degree in Earth observation science or geoinformatics, paired with contextual expertise and/or additional degrees in environmental science. We'll listen to you.
Hello everyone. Thank you so much for the introduction, and thank you for inviting me. Here we go. So indeed, again, thank you so much for the invitation. I'm Federico Franciamore and I work as a GIS remote sensing specialist at Space for Good. What I'm going to do today, well, first of all, I come on behalf of Space for Good as a well-introduced. We are a social enterprise based in Den Haag, in the Netherlands. And representing probably today a bit the technology part of this domain. I will introduce a bit Space for Goods and the project and applications, and then talk about what was our contribution at the More Than Planet set of workshops, and I'm here for questions. We are based on three main pillars: remote sensing, geoinformation systems, and AI, artificial intelligence. Quite a hot topic right now. But the main goal of Space for Good is to create and analyze data, Earth observation data for social and environmental impact. We started our journey back in 2017 at the European Space Agency BIC, the Business Incubation Center in Noordwijk. And since then, we've been cruising a bit around till coming to the certification of B Corp as the first ones in this domain in 2020. And now we have more than 20 team members, full-time employees working on environmental issues. What we want to get to is to become the most trusted geospatial solution partners for impact leaders. And what we offer to our client usually is remote sensing data, geospatial analytics, creating models and predictions, and obviously with the goal to monitor and report on specific features and landscapes. And I will show you in a bit what are these applications. We always try to work together with local partners, so we stay away from companies or pipelines that just provide insight using merely remote sensing Earth observation data. But we want to always embark in this feedback loop that comes from in situ validation as well. So often in many of our projects, we talk before with the clients that have, or partners that have experience in situ. We developed the model, we co-developed the algorithms and the solution, and then we ask this validation in situ. And we find ourselves often to display then this data in geospatial platforms or specific APIs that are plugged into already existing platforms. So we provide the data through these two main ways. Part of our work is as well to work with to bring knowledge on GIS remote sensing through workshops or events like this. We are active on four main sectors. I have to say the first two are for the most the ones that we are more active in: agriculture and forestry, so nature-based solution, biodiversity, working there for establishing actually new parameters and set of parameters that can link biodiversity and biodiversity loss via Earth observation. And then we have a couple projects as well on peace and justice, working in war zones, mostly pro bono works, or climate and infrastructure monitoring. We're active in more than 50 plus countries. I have to say the tropical and subtropical area is for the most usually what we check and monitor with. And why so? Because we are often work on deforestation or afforestation projects, and this project take place in these areas. Starting for the project or more the application that we developed, we have here the first project that we started with. It's called Reforester. This project started to check on 200,000 hectares in Indonesia, privately owned. And the partner came to us and asked us, okay, we have this huge piece of land. We don't know how to monitor this efficiently because there is a lot of encroachment, a lot of illegal activities going on, deforestation, one of the biggest problems, and the fires that are associated to it. And we start to design together, first of all, analyzing all the requirements, analyzing all the issues that were occurring in the area, and coming to the, creating a mock-up of the platform, and then coming to the actual mock-up that has two different, let's say, versions. One is more for the executive, let's say for non-expert public, just summarizing events, summarizing deforestation events or fires in the area. And another one is more for the R&D team, or the team that it goes in situ. And to explain you as well about the complexity of the project, besides all the parameters and problems that we measure, like deforestation, biomass, fires, we had to as well build ex novo a road system, digitalizing manually all the roads, because obviously in this area, in the middle of nowhere, in the Borneo Islands, we don't have such data sets. And then we created a mobility package. So the team in situ could move easily or establish activities to check illegal activities faster. So a lot of data were used in this platform, but and this project was the first one at Space for Good that allowed us to develop many other projects. And one of them is, for example, the biomass estimation. We work with the Rabobank in the Netherlands to estimate biomass for small older farmers that can regreen the area, and Space for Good acted as a technology party. Imagine there are thousands of plots that needs to be checked, and with the use of remote sensing, in this case we use some radar and LiDAR data as a training samples, and we scale up with the Copernicus data, Sentinel-1 and 2. We could check all the biomass of these sites. Not only biomass, but as well afforestation project. Imagine maybe you know Ecosia, this searching engine where you can look for whatever you need to as a Google, but every time you do a research, a tree is planted. And obviously Ecosia don't plant the tree or themselves, but they ask other partners all around the globe to plant trees. And so they came to us and they asked us to understand if there was a way through Earth observation to monitor these plots, and not only monitor a plot level, but as well within each plot, what are the area that needs more attention. So imagine there are plots that are performing better, and we create health indicators to analyze those plots, especially looking as well at the entire time series. Not only afforestation, but also deforestation, which is the other problem, mainly in the same areas. We work, for example, with the Amnesty International to map deforestation events in areas where not only we can check and validate, as in this case in our area in Borneo. You see these little images for the events that we register, we send people in situ, and those are the proofs that actually something was happening. But as well in areas where it's not possible to go, and this was the case for Amnesty International in Cambodia. I was talking before about biodiversity, and biodiversity comes with a really hot topic right now because obviously takes not only the carbon aspect, so not only the trees, but as well all the, let's say, complexity and other species of a specific ecosystem. And mapping biodiversity from space is quite difficult. Biodiversity can get to a lot of hundreds of parameters. We are now lucky to be one of the major actors in this, participating in this big European call with the big consortium to establish which of these parameters make more sense. But in this case, we now participating, and now in June, a couple team members will fly in Singapore to participate to this X Prize challenge, which is basically the challenge is to map biodiversity of 100 hectares in Singapore without accessing the area, so without interrupting any processes. as human beings, but we decide to fly some drones, to use high resolution imagery with different type of, let's say, spectrum of data, from optical, multispectral, or even thermal. And we partner with a company who actually can collect from a sponge, which is mounted on drones, water samples, and to collect and analyze eDNA. So not only tree species that can be detected by the drones, but as well animal species. Another example is fire detection. So, and this is again as well super challenging, because as you can imagine, to act on a fire that can be spread quite rapidly, we need near real-time data, if not real-time. And this is an example on how for any of these applications, or if we want solutions, we always have to balance between what is the resolution, the spatial and the temporal resolution of the Earth observation data. Often, as I said, the problem of deforestation in this area where illegal encroachment happens is linked to the deforestation. So the deforestation happens after, the fires happens after deforestation to clean up the land. Another topic and project that we've been working on is the health of vegetation systems and pest and disease spread as well in India as in Europe. We work with the Canton Bern in Switzerland to create a risk mapping of bark beetles. So bark beetles are this little insect that actually start to eat the pine's bark, and those brings to the death of the forest. So mapping what are the risk areas as to give insight on how rapidly to act on those risk areas has been part of our work too. And this goes into the domain of the suitability mapping. So another project could be, for example, where and when to release a specific wild species in an area. I found myself, for example, working a small project in Indonesia where we had to release two tigers. And obviously, releasing a tiger means that can cause issues for local communities. No one is really happy if you have a tiger in your garden. And in that case, we collected all the requirements. For example, how far a tiger, this, let's say, ideal place has to be from farmers, from urban settlements, and what are the habitats. And so we created this map that overlaid with the land use was useful to find this best spot to where release these two tigers. Before I mentioned that we active often in the context of social justice, but peace and justice as well. And this is an example of a project that we conducted in war zones to look at unexploded ammunitions. Imagine we have this data set of bombs, mines that were launched, and then in this case, the two organizations, the Carter Center and the Allo Trust, ask us to look for changes in landscape to understand if these ammunitions were exploded or still could possibly be in situ in the field. And for this type of, these images is a nice example of the variety of data that we use as Space for Good. In this case, we used Sentinel-1, so a radar image, which is most of the time a bit more complex to analyze and to understand because it comes with a lot of noise. But the good part of these images is coming from an active sensors is that is collected every 6 to 12 days, even at night, and clouds are not interfering in these images. So we can have rapidly an image, let's say, as soon as it's collected from the satellite. An example instead of not only land monitoring, but in this case is what's happening in the troposphere. It's about the emission monitoring that we conducted with the World Bank. And here is curious to understand as well what is the granularity of the data that is needed for a specific project. In this case, the World Bank asked us to first of all, look at what was the possible data that could be used to monitor NOx, in this case in Indonesia. And we did this before, during, and after the pandemic to understand if and compare this with the GDP values to understand if the even emission data could be used as a proxy of how rich or doing well or bad is doing a country. And as you can imagine, we soon realized how, well, during the lockdowns, GDPs went down, and as well emissions were down because of mobility data or the industries. But as well, studying and looking at limitation of data too. There was an area close to where no cities or special mobility events were happening, but highly polluted. And looking just at these boundaries of Indonesia, we couldn't understand why this specific region had such high values of NOx. We had to look at the wider picture and remove the country boundaries to understand that this area was super close to Singapore. So even if this area was not referring to a specific industrialized area of that country, being on the air, the winds would bring this NOx all over. So as well, an example of how space data help to understand better the Earth system, but never forget to contextualize this information. This is a fun story. Well, fun because when I present this project, is always say that we count toilet from space, and is actually a project that we conducted with AMREF Health Africa to an example of infrastructure monitor. When we've been asked to count and first localized and understand where latrines were in Uganda. And the goal of the project was to understand the distribution of these sanitation structures, to allow the organization to intervene in specific areas where, well, highly dense populated and know a lot of toilets, latrines. And we did this with a special technology that does require quite a lot of GPUs and requires a lot more, let's say, computational programs, because machine learning is not enough for this type of tasks, but we had to go into the realm of deep learning. So training the model first, each latrine has this specific pipe that can be recognized by human eyes, and so by the model, and we could count latrines from space. This is one of the latest projects that I was involved in one of the municipality in Germany, and as well in the realm of the infrastructure monitoring, how Earth observation and remote sensing in general help us, well, policies and in this case taxes too, or the tax system. So we worked to analyze the paved and unpaved areas of this municipality, where the hometown want to understand what was the surface that you would pave of your garden, because more surface you paved, more you pay. And why so? Because obviously, if there are more surfaces that are paved, then this can bring to a lot more issues with runoff when heavy rains occurs. And this is especially super important as well now in these days where we hear that there are a lot of areas that are affected by floods and issues like that. Yes, I'm finished. Cool, thanks. Well, this is just an example of what are the key benefits of using as well and displaying data in a digital form, in a platform. Obviously, our work today exists at Space for Good because there was this, let's say, moving from paper map cartography to a digital form that allows us not only to look at features, but as well to look at features in a stack of layers. We can overlap in a digital form different informations and extrapolate inside. And obviously a digital platform allows us to show these different layers really rapidly and in a more meaningful way. But this is an example as well of the technology, what the multispectrality of data allows us to do. This is the same image, but with different band composition. And it's an image that I analyzed for Sicily, where active fires, wildfires destroyed forests and fields every year in summer. As you can see, in certain band composition, it's even able. We are even able to look at the line of the fire. So, according to different band composition, we can actually make and analyze different features. These are a bit the displayment of all the partners and clients that we work with. So as you can see, a lot of university and institution, but as well NGOs and private companies. And I will finish my presentation as well with instead bringing a bit here on the table what was my experience at the set of workshop organized by Bach, where, well, besides the process and the, let's say, contribution that is more giving data and tools advice or giving feedback on specific clustering of topics that the participants, as our scientists or artists, are bringing on the table. It's maybe a bit more reflection on personal reflection on how this experience is bringing me and looking at the problem or the same problems, less solution in a different way. So from artist perspective, we don't do that at Space for Good. We are just working with data and give insight to the client, more in a consultancy type of process. But as well, being part of this experience of More Than Planet workshop give me, and look at all this presentation as well of today and yesterday, gives me this different point of view on how the data can be seen as well in our artistic form, and how can sensibilize the public and the wider public more than we do at Space for Good. Thank you.
Thank you very much, Federico. Any questions? Maybe you could tell us in a few sentences what were the specific demands you got from artists and how you managed with them, or how you worked with them to make them, suitable to what you could do.
Yeah. Well, what I would say first of all is that with the fact to work with artists allows me to think a bit more out of the box. We know a specific technology, specific tools and data that we can use to solve tasks. And instead, in this project, I've been more thinking we don't have to solve tasks all of the time, but we can just even create feelings or create a message and deliver this message with a specific, probably database approach, but still the important thing is not to deliver that specific number or that specific value. In this case, the users will have to feel and to have to experience that. So shifting this focus from that. So something that I learned. And then obviously as well bringing back to the artist the experience of the limitation of the data too. It's always like a trade-off on what it's available for free, because often this data can be quite expensive, and so learn express this into possibilities and limitations.
Thank you.
Yeah, I have a question. Do you ever come across situations with your Earth observation platforms where you have to remove information or switch off your camera because of military sensitivity, or there's something that that maybe a government would not like you to put into an open source context? Does that ever happen?
No, this wasn't happening to us. I have to say, especially for this project, we found ourselves working for pro bono when like a war zone or same thing happened with the situation in Ukraine. We had some requests saying, you have the access to this data, can you help us? I remember being in contact with commercial entities that can obviously retrieve and deliver data that are faster and more spatially accurate. Remember the specific request was to count cars that were going away from the war zone. And here what I noticed is there are some companies that are more willing to help, and other ones that have agreement with military services where they can't deliver data at one point anymore. This is the difference that you see, but there was never the case to be, let's say, interrupting into these processes. On the other hand, I wouldn't say military, let's say, interruption or the things that are, we avoid to do that. This comes more often from the client side. Imagine in this area in Indonesia where we have super high valuable tree species, and if we know the location of, everyone knows the location of the tree species, then we almost give them the tools and specific location to where to harvest the species. Same things is happening now with the project that I'm working on for primary and old growth forest in the Western Balkans, working with 7 countries where we're trying to map the ultimate primary forest in Europe. If we would share this data tomorrow, we would never know, in an open source platform, we would never know if this data potentially goes to the wrong hands and could harm as well these forests and ecosystems. So let's say in this case it will be more for us, and this is how we will take this approach. For example, we will deliver this insight to the company, the foundation that asked us to do this exercise, and then we'll be on their ends and looking at the strategies on how to share and maybe downside in resolution. But indeed, there are some sensitiveness in what we share, so it's not always, or what we found out, so it's not always the case that we openly share to everyone. It has to be discussed and strategized with the clients and partners and institutions.
Yeah.
So just a comment on that. So basically, you're getting all your data from third parties.
No, yeah, we don't have our own satellite systems. Obviously, we rely on mainly on the Copernicus ISEA, the European Space Agency Copernicus program, coming with a set of satellites that can measure different things with different systems. Obviously, with this comes some limitations, possibility, but limitation too. This satellite data have 10-meter resolution. Whatever is smaller is not possible to be detected. When we want to look at things a bit more in detail, then we have to purchase images or imagery from commercial entities. Airbus, Maxar, Planet, and this comes with a cost and obviously we have to trade off of how sustainable it is to look at or purchase all these images for an entire country, for example.
Thank you very much, Federico.